Welcome back, everyone, to Data Analytics Chat, where we explore different topics in the evolving data science and AI world. Today, I'm actually live from Bali, so hopefully no technical issues, fingers crossed. I'm looking forward to discussing today's topic, is where we look at the railway industry and the impact that data science and AI has had. So today's guest, I'm delighted to welcome Olga Spackova, who is a data science team lead. Welcome, Olga.
Welcome. Thank you, Ben, for having me here.
No problem. So do you want to quickly, briefly introduce yourself?
Yeah, so I'm Olga Spackova. I am originally from Czech Republic. My background is actually in civil construction engineering, but quite some time ago, I got excited about research. I moved to Munich now 14 years ago. I was working in research at the Technical University in Munich in the engineering risk analysis group, where we basically focused on data and models to estimate safety and reliability of technical systems from, buildings, bridges, to airplanes, ships, offshore structures, different things, and then quantify the risk and optimize the system so that they are safe enough, but at the same time cost effective and usable. And then I moved back to industry and I joined a Munich-based AI startup focusing at that time on predictive maintenance for railway switches. Today, the portfolio is a bit broader, but still this is the main topic where I'm working on. And I've been very happy there since then.
Brilliant. Good. Now, I've also mentioned, look on the LinkedIn profile, you've sort of been, like myself, worked in a number of different countries. So I think it's always good to expertise.
Yeah, it was always very interesting. But now I have been in Munich for 14 years.
And so is that going to be, you're going to be settled for Munich for the future now?
I don't know, but I'm very happy. It's a really nice town close to the mountains, and there is very vibrant now startup culture. So it's really a lot of interesting things happening here also professionally.
Yeah, brilliant. Cool. Okay, cool. So obviously you've worked for a railway company. But can you provide an overview of how AI is currently being utilised within the railway industry?
Yeah, so I actually personally didn't really work for a railway company, but it's of course our company KONUX main client. And AI and generally digitalization is a big topic in the industry. There are many projects and initiatives that support the development in this field. I don't know, for example, in Germany, we have the Digitale Schiene, so digital rail, or a house of AI. And basically every of the railway companies today has internal data science analytics teams who focus on the digitalization and implementation of AI. What is my experience typically is that because a lot of these projects are kind of project-based, kind of short-term initiatives, they sometimes don't really long for very last. So the initial ideas, which are really often very interesting, then don't get to the users. There is not the continuity in maintaining the tool, the software, and so on. So the other kind of traditional thing how railway uses the AI or the digital systems is by buying different hardware systems, right? So there is a lot of development in monitoring systems for both the rolling stock, so for the trains, for infrastructure, where you have, for example, monitoring trains equipped with camera, lasers, ultrasound, eddy current, which monitor the track and the environment around. And these data are then used for planning the maintenance and checking the health of the systems. And then what we are doing, we basically focus, we also have our own hardware, but we focus more on the analytics part, so on developing the models and adding the interpretation layer to the data. So basically, we provide as a SaaS solution where we constantly develop and improve the system as it is in operation.
Cool. So I guess the big thing is around safety, I guess, is you can identify the safety issues a lot better.
Yes, so I mean the traditional way, so the safety definitely is a big topic in railway, right? So it's basically probably the safest mode of transport that we have now, also environmentally friendly. So it is already very safe. And there traditionally the way how it was done was that people were going to the track, inspecting the track, deciding about the maintenance. So it was very much based on expert knowledge, which today is a big problem. So one thing is this is very dangerous work. The other thing is that there is actually lack of these experts and the problem in transferring the knowledge from to new generations, right? So that's why there is big hope in this emerging digital systems, which can add and ultimately hopefully also replace the human expertise in needing to inspect the track and the rail, the trains.
Okay, cool. So what the specific challenges or pain points does KONUX aim to address?
Yeah, so the oldest project that we have is focusing on predictive maintenance for railway infrastructure. So the issue of railway today is that there is increasing demand and aging infrastructure, right? So the number of trains is increasing. You have practically no possibility to extend the infrastructure, at least in countries like in Europe, because there is no space to build a new track. So the only way what you can do is to increase the capacity of the existing infrastructure. So this is the goal of the predictive maintenance. The other thing is to minimize the time that the people have to spend on the track, the people responsible for maintenance, because it's a very dangerous job. You either do it in the night or you do it during the day, but then almost at full operation, which is really not such a great experience. So this is one thing. And now we are also focusing on traffic modeling. So basically, understanding where delays come from, and then using the data to optimize the schedules, but also kind of the real-time operation. So decision, okay, there is actually a delayed train. So what should I do with the other trains to minimize the negative impact and minimize the delays? And I mean, I think ultimately the goal would be to join the different data sets and words. So currently, even on the track monitoring, you have like different people focusing on different parts of the track. They don't share the information with each other, right? They only look at kind of small part of the world. So the data and the decisions are very siloed. And the goal would be to join this and have information from maintenance for the planning of the traffic and the opposite way, and ultimately also join the data between different mobility transports.
Yeah. So I guess there's a lot of data.
We have a lot of data.
So that's a hot topic at the minute, isn't it? Around the data management aspect. And I think everyone's obviously, I think it's just a massive hot topic. So, I mean, how did your data team then approach to the data collection and analysis of data?
Yeah, so I mean, that depends a little bit on the application. So as you said, the most original product is based on actually a lot of data. So we are recording acceleration data of the track when a train is passing, which really means quite a big volume of data. I don't have the exact numbers. I didn't check with our data engineering team, but I would estimate that now we are recording like 500,000 traces per day, where each trace has, 100 kilobytes or something. So it's really like quite a challenging data engineering problem to transmit, process effectively, and so on. But I mean, it's not the only source of data. So I mean, to give some meaning to the data, we also need, kind of contextual data information about assets that we monitor. So to a layperson, it might look at all the infrastructure and all the switches. So we monitor mostly the switches, so the places where the train can decide whether to go left or right. I think it's turnout in the British English. So they can appear to be very similar, but they differ in many different parameters. So this is like a type of information that we are also collecting either from our customers or when we install the monitoring systems. One big topic for us is the ground truth data. So again, to derive what we see in the signal, we need to understand what is actually the health state, what are the failures that we see there, and so on. And this is quite challenging. So one approach we take to this is we use the data from like maintenance management systems of our clients, where they record results of the inspections and information about which maintenance they did. So the advantage of this type of data is that it covers basically the whole system, but at the same time, it's not very granular and also not very accurate very often. So to go a bit deeper and get the granularity that we need, we also try to incorporate like a feedback loops into either directly our product to get feedback from the people in the field or through our customer support people. And we also do reference measurements sometimes. So we go to the field, we measure the state of the assets, we test different new sensing systems and so on.
So quite a few different approaches.
Yeah, many different. We have to be quite creative. So it's not so easy to get the data, but yeah.
Cool. And what's the key benefits that AI is bringing to the industry?
So, I think like in every other industry, AI has enormous potential, right, to generally automate a lot of the processes. So we spoke about the inspection maintenance processes, where this would be the ultimate goal, to automate this and actually improve them with these systems. You can see more than you can see with visual inspections or some simple measurement systems which were used in the past. And besides the topics that we already discussed, I think generally it has the potential to significantly improve the passenger customer experience, right? When you are a passenger today already, you will meet different AI systems in delay prediction, in management of the passenger crowds in train stations and so on. So there definitely is enormous potential.
Yeah, I guess there's lots to be done, but it's a lot of work as well.
Yeah, there is still some work to do for us, but
it's never ending. It's always things to be improved and new things. So interesting times ahead, I'd say. So honestly, just I guess touching base, obviously around the data, key topics a minute around like data privacy and the ethical use of data has been quite an important topic recently. So how do you ensure the ethical and responsible use of like AI technologies within like your company's solutions?
You mean in our company mostly?
Yeah. Within like the solutions you provide.
Yeah. So on general level, I think we really overall try to, make people aware of the risks and limitations of these tools, and we have very strong, I would say, culture of ownership in the company. So kind of everybody, the C-level to all the engineers is really, I think, thinking about the product that we are developing and what we give to the world. And in case of any, concerns, they voice the concerns and then we internally address them. In terms of the ethical issues, I think we are not the most, this is not the most critical topic for us, right? So, we are not developing system which is deciding about who is invited to interview or gets a job or so we really focus on technical systems. but the safety definitely is a topic, right? So the need or the responsibility for developing a system which our customers can rely on.
Yeah, good. No, it's a good point. Like I said, like everyone gets involved, because I think communication's the key for most businesses, because I think that's where most businesses struggle, is the communication aspect, because obviously there's so many different layers within businesses, I think, and it's hard to obviously align, I guess. So I think that's one of the biggest challenges.
We have advantage that we are a relatively small company, right? So the communication is very easy. You can talk to the CEO at the coffee machine, and it's like much less complex than in case of our clients who have tens of thousands or even hundreds of thousands of employees. That's for sure difficult.
Yeah. And then, so what role, let's move to like machine learning. What role does machine learning play in your solutions for obviously your railway sector?
So we do have machine learning, but I think the thing which I love most on the application where I'm working is that we basically have everything, right? So, we have sensing data. So we start with signal processing, so classical kind of engineering from filtering, time, frequency domain analysis. We have amazing statisticians in the team where we use methods for, change point, trend detections. We use Bayesian hierarchical models, mixture models to correct the variables we are producing. We have machine learning for classification. We have AI, neural networks for image processing, where we transform some of our signal to image-like data. But I think the thing which I'm like most excited about is, because also I was like fighting for it, and it's kind of unusual, I would say, in the data science work, is that we also combine like classical engineering simulation models. So models like finite element models, multi-body simulations, which have been used in engineering for several decades already, to basically simulate the real structures like bridges. So in our case, it's the track or the switch. So there is like enormous knowledge of the engineering where you model the materials and the connections and everything. And so one thing is you can use it for like experiments. So you don't have to go to lab all the time or something in the research phase, and you can understand the system and play with the parameters and understand what happens. But now what is exciting is we also managed to reduce the model. So normally a model like this runs hours or even days, right? And if you want to use it in like the online system like we have, you have to significantly reduce the size. But this then gives us the possibility to really learn from the signal that we have a lot of information about the actual switch, like how is the wheel passing, what are the forces that the train is putting on the rail, and really super exciting things. So this is really something interesting. And then, we also experiment with the hot topic, which are the large language models like recently, right? So we don't have a lot of text data, but we were, for example, experimenting to use them in interpreting the data, the outputs that we see in understandable way for our users.
Yeah, you also see LLMs is the buzz. It's a hot topic. Well, how do you see like Gen AI technologies contributing to the innovation within the industry for you?
So, as you said, the Gen AI is pretty new topic, and generally the industry is not the fastest in implementing. So I can speak from our side. We definitely already use a lot of Gen AI tools in our own work, and I don't have like exact numbers because we are a small organization, so I cannot say how much the productivity improves, but I think there is like a very considerable impact on the productivity, both, in marketing, in content generation, in image processing. but also in engineering, where we definitely use the code helping tools, right? So like Copilot, we use LangDoc and so on. So that's definitely in the industry. I think I cannot really comment in detail.
Yeah. Okay. So do you think do you think it'd be further down the line there, Gen AI will be utilized more?
So I mean, like in the future, I'm sure it has potential to automate a lot of the processes that are there already now, right? So I mean, even in the maintenance, I think the ultimate goal would be to, from the monitoring system, to automate the whole process of, ordering the maintenance works, ordering all the parts for the maintenance work, and ultimately it could be even robots going to the field, right? So there is enormous potential. What I'm saying is that even with the systems that we are now developing, the implementation is rather slow in the industry because it's like traditional. So I guess for the Gen AI, it will take a bit longer than in other industries. But yeah, let's see.
Okay, cool, interesting. And then how do you integrate AI systems with like the rail infrastructure and technologies? How do you go about that?
How we integrate?
Yeah.
So, I mean, I think we have different modes. So there is the integration of like how we integrating our insights into, so the output from us to other systems. There, our preferable way or the best experience we have is actually we have our own UI, and we prefer if our customers use our UI because it's much faster to deliver a new value, right? So we are constantly improving the models, deploying new features, improving the system. And in the AI, it's basically immediately. We also provide integrations into systems of our customers if they prefer to, because sometimes they, for example, don't want their employees to use too many systems and so on. So they want us to integrate to some other platform that they are using. There, it's difficult, right? So the implementation, every change, and the value that you can deliver through this integration is much lower because they are not built to represent the data that we have originally. So that's one point. And then the integration. So, I mean, I spoke about all the data that we are already using. Yeah. So we are not only using our sensors, we are now using also third-party sensors. So, for example, for monitoring of the point machines of the engine, there are already solutions that have been developed and which are installed in the field. So we ingest this type of data and analyze them and then provide the insights. We also really like to integrate the maintenance management system data, so the information from inspection and maintenance, because it on one side can help us to, evaluate our system and constantly improve it, so retrain the model. And also, for example, knowing about the maintenance then allows us to evaluate how efficient the maintenance was. So we, to some extent, we are able to detect it with our system, but that means that we have to send a lot of traces to catch this one where the maintenance machine was there and so on. So this is something what we really like to do. Yeah, I think that's it to the integrations.
Okay, cool. And then I guess what's some of the big technical and like regulatory challenges that you face when you like deploy these solutions?
Technical and regulatory. So I mean, generally, I think the problem that we are trying to solve is technically not easy. So on one side we are developing the sensors, where I mean the challenge is not so much in the sensor, or the challenge is in the requirements on the sensing system, where you need it to survive very harsh environment, where some of our 500G sensors are saturating on some of the locations. So it's really very unusual in condition monitoring in applications. And you need them to survive basically for 5+ years without any maintenance. So it's really challenging to develop system like this. And you have certain limitations. And then also the models that we are developing, right? So there is quite a lot of research in vibration-based monitoring, but it's not, that it would be solved, and every of the application is quite different. So it's challenging problem. I must say, when I joined and when I came to this field like 5 years ago, and I saw, where we are and how technically difficult it is to get there, and like what is the gap between the vision and where we are, it was like I was like the skeptical engineer who was not certain about if we ever get there. But I must say that in the 5 years, we made such a great progress. And today, even if the system is, of course, not perfect yet, I'm now very confident that we can really diagnose and predict the damages on very accurate level. So it's very, I would say, satisfying and exciting. To the regulatory, that's, I think, more challenging part. So, I mean, as I said, the railway is very safety oriented, which totally makes sense. There are like regulatory bodies which basically have to certify, approve every new technology, every new process that the railway operators use. The problem is that I think the regulations and the regulatory bodies are not really ready. So you have to use completely different way of evaluating AI system from measurement system as they were in the past. And this, I think, is like a big, step the industry has to do to be able to certify these systems and to really use the value, because currently the systems are used kind of on top of the existing inspection maintenance, so on top of the people, and it's still the people who are responsible for making decisions and so on. But if you want to automate the processes, you will have to prove that basically the new systems are at least as safe as the traditional ways of doing maintenance. And there is not much happening so far. It's kind of interesting because in other industries, I think they are much farther. So if you look at autonomous driving, there is a lot of activities. Every company is developing like a safety concept to prove that the autonomous driving cars are safe. But in the railway, it's still not very advanced.
Okay. So you did touch on obviously this, how you measure it. So how do you measure like effectiveness and impact of your AI solutions in improving like the railway operations? And
I mean, the ultimate and most important KPIs for us will be reduction of delays and the reliability of the system. So, what is the probability of detection of important failures? What is your false alarm rate? So how many times you say the infrastructure is damaged when it's not, because that's the important thing to prove that the monitoring systems are reliable. So we know how we would like to measure it. The problem is on the accuracy of the monitoring system is with the ground truth. So you don't really have the data to compare it, to calculate the KPIs. For the delays, I mean, I think, that will be also challenging, because once you basically implement the systems, then you can compare how the delays were reduced. But of course, the challenge is if there are other external factors, how you attribute it to the system. But that would be, I think, the most important PIs we need to focus on. So we measure also many other things, but in terms of how to measure the value of these systems, these are the most interesting metrics.
Yeah, definitely. Obviously, ROI is key. So just to end it on then, what obviously we touched on the AI data science is there's a lot that can happen. What do you think? What's your future? What do you think the future holds, or future trends in the sort of the railway industry?
So I think some of them we already touched, right? So I mean, I believe that the industry has to go into the direction of like connecting the different data sets and systems together to provide more value, optimize decisions, certifying the system. So I mean, really changing the processes in the maintenance, in operations, so that you can replace the human contribution and really make use of these systems. And I think one thing which definitely is very interesting and where also we have to go more is the topic of making the systems actually more efficient. So I think you had actually some podcast some time ago on tiny ML, which definitely for us is super relevant as well, right? So to, on one side, make the models smaller, but also optimize the data that we are transmitting. How are we selecting them on the sensor, do some processing directly on the edge, select only the minimum amount of data that we need and transmit only that. That's definitely something what we will, and not only we, but everybody will need to do in the future.
Yeah, so a lot there's a lot that can be done, I guess.
Yeah, there is still room for improvement, but
brilliant. Cool. Well, thanks. Really appreciate that. It's been some brilliant insights into what KONUX does in the railway industry. Thanks for being on the podcast. It's been lovely having you.
Thank you very much for having me here. It was a great experience, my first one, but definitely I enjoyed it very much.
You smashed it. You smashed it for your first one.
Yeah. Thank you.
Brilliant. Thank you.